Hello everyone, I am Suchita Morir. Welcome you all in the video lecture on the topic Differential Calculus Leibniz Theorem. Leibniz Theorem is applicable for finding a net derivative of the product of two functions of x. Therefore, v its net derivative is unv plus nc1 un minus 1 v1 and so on. Here, this nc1 value is equal to n and nc2 value equal to n into n minus of 1 by 2 factorial. Now, then uv its derivative is unv plus n un minus 1 v1 then n into n minus 1 upon 2 factorial un minus 2 v2 and so on. That means the first we find out n derivative of u. In second term n minus 1 and n minus 2 and so on. And here for v, for first term we write down as it is, then first derivative, that means increasing the derivative of v and decreasing the derivative of this u term. In this way we apply this formula A, that means Leibniz theorem, for finding nth derivative of two functions possessing derivative of nth order. Now, for example, find nth derivative of y equal to x square e to the power x. Now here, one is algebraic term, second is exponential term. Now we write down the apply here Leibniz theorem. Here this is the equation number 1. Now here x square is the algebraic term, therefore we consider this as v, and exponential term, that means continuous function, we consider as u. And then apply this Leibniz theorem. E to the power x, its a derivative, plus v as it is, that means x square. Then n, this n as it is, here u its n minus 1 derivative, and derivative of x square is 2x. Similarly, third term n into n minus 1 upon 2 factorial, then u, that means e to the power x, its n minus 2 derivative, into v2, v2 is twice x, its second derivative, x square its second derivative, therefore first derivative is 2x and second derivative is 2. Now next derivative is 0, therefore there are three terms in a derivative. Now we simplify these terms and write down the answer. Now we know the formula for a derivative. If y equal to e to the power ax, then n derivative equal to a to the power n e to the power ax. By using this formula, we write down the values of n derivative. Now here n derivative a value equal to 1, therefore 1 to the power n e to the power x. Here x square as it is. Plus here twice nx. Then here n minus 1 derivative. Suppose here yn equal to this value, then yn minus of 1. That means n is replaced by n minus 1. Therefore we get these values. A to the power n minus 1 e to the power ax. Therefore, now a value equal to 1, therefore 1 to the power n minus 1, its value 1. Then e to the power x as it is. Now third term, n into n minus 1 upon 2 factorial e to the power n minus 2. Now yn minus 1 equal to this value, therefore yn minus of 2 equal to a to the power n minus 2 e to the power ax. That means n is replaced by n minus 2 in this formula, and write down the value. Therefore, e to the power x into 2. These two get cancelled, we get a required result. In this way, we find out the nth derivative of x square e to the power x term. Now second, Find any derivative of x cube cos x, it's an derivative. That means here we consider u as cos x term and x cube as v. Then apply the Leibniz theorem. U, it's an derivative. V as it is plus n, then cos x, that means u n minus 1, v1. Therefore, derivative of x cube is 3x square plus n into n minus 1 by 2 factorial. Then cos of x, that means u n minus of 2 into derivative of 3x square is 6x. Now it's another derivative also exists, next derivative also exists. Therefore, next term is n into n minus 1 n minus 2 upon 3 factorial into cos x, it's n minus 3 derivative into 6. Now next derivative of 6 is 0. Now we simplify the formulae. Now for this cos x, we apply the derivative formula whenever y equal to cos ax plus b. Then yn equal to a to the power n cos of ax plus b plus n pi by 2. And if we find out the value of y n minus 1, here n is replaced by n minus 1 and write down the value a to the power n minus 1 cos of ax plus b into n minus of 1 pi by 2. Now n minus of 2, then n is replaced by minus 2 and find out the value of y n minus of 2 in this way. Now here x cube as it is, cos x, its derivative by using this formula. We write down this value cos of x plus n pi by 2. Now secondly, the derivative of 3x square n term here, then cos of here x plus n minus 1 pi by 2. Third term n into n minus 1 upon 2 factorial into 6x. Now next derivative is cos x plus n minus 2 pi by 2. Last term is n into n minus 1, n minus 2 upon 3 factorial into 6 cos of x plus n minus 3 pi by 2. Now this 6 get cancel here. We reduce the form and write on the last answer. In this way, for simple function, we can easily find out the net derivative of product of two functions of x. Out of this, one is algebraic term. That means whose derivative will be 0 after 2, 3, 4, 4 derivative. And u is the continuous function. Now, example number 3, if y equal to cos inverse x, then prove that this first result and second result. In first result, highest power of higher derivative term is y2. Therefore, we differentiate this y two times, then we will get the first result. And in second result here, yn plus 2. That means this first result, if we differentiate n times, and here algebraic term product of two functions of x, therefore we here this x term 1 minus x square term, y2 term. Therefore, we differentiate n times by using Leibniz theorem and find out yn plus 2. That means second result. Now here consider y equal to cos inverse x, y1 equal to minus 1 upon under root 1 minus x square. This is the first derivative. Multiply by denominator term, that will be easy for us. Therefore, multiplying by denominator term, we get equation number 2. Again, we differentiate this equation number 2. Therefore, this under root 1 minus x square as it is, derivative of y1 is y2 plus derivative of under root of 1 minus x square is 1 upon 2 into under root 1 minus x square into derivative of this 1 minus x square is minus 2x. Y1 as it is here, 2 get cancelled. We get first result. Equation number 3, that means first result. Now we differentiating this first result n times by using Leibniz theorem. Therefore, this is the Leibniz theorem. We use here equation number 4. Differentiating n times. Now here this we consider this value as u and this value as v. for applying Leibniz theorem. In second term here, this continuous term y1, y2, we can find out its standard derivative. Therefore, we consider this as u and algebraic term as v. Now, we are applying this equation number 4 here. Y2 its standard derivative. V as it is 1 minus x square. Then plus n into y2 its n minus 1 derivative. V1 derivative of 1 minus x square is minus 2x. Plus next term n into n minus 1 upon 2 factorial y2 its n minus 2 derivative into minus 2. This is the first term. Now second term minus here y1 its n derivative into x plus n into y1 its n minus of 1 derivative into y. Now the x derivative of 1 equal to 0, therefore its value equal to 0. Now we simplify these terms. Now for simplifying these, y2 its nth derivative, that means in simple way we have to write down n plus 2, that means addition of these terms. Now here y2 it's in second term here y2 it's n minus 1 derivative, that means y it's 2 plus n minus 1, that means here we get n plus 1 term. In this way we simplify this. Therefore here y2 it's an derivative, that means yn plus 2, then 1 minus x square plus n. Here second term y2 n minus 1, that means here minus 2x is outside, then yn plus 1. Next term here 2 get cancelled, here negative sign minus 2, sorry, minus 1 into n minus 1 y, here 2 plus n minus 2, that means yn. Now next term is minus x into yn plus 1 minus n yn. Its value equal to 0. Now we combine the terms of yn plus 2, then n plus 1 and yn. Therefore, here if you observe the terms, here only one term of yn plus 2, then yn plus 1, that means here yn plus 1 and here yn plus 1. And here yn. Therefore, we combine all these terms. Yn plus 2, only single term is there. Therefore, 1 minus x square yn plus 2. Now, second term, yn plus 1 is minus 2nx yn plus 1. And next term of yn plus 1 is minus x n plus 1. Now yn terms here minus n into n minus 1 yn minus nyn, its value equal to 0. Now combine these two terms, 1 minus x square yn plus 2, this is as it is. Now these two terms we taking x and yn plus 1 common, therefore here we get twice n plus 1 into xy n plus 1. Now next term, from this we taking minus sign common and yn common, then remaining term is n into n minus 1 plus n. equal to 0. We simplify this. 1 minus x square yn plus 2 minus twice n plus 1 x yn plus 1 minus, now this term is n square minus n plus n 1n equal to 0. This term get cancelled with this, we get the required result. Here 1 minus x square yn plus 2 minus twice n plus 1 into x yn plus 1 minus n square yn equal to 0. This is the second required result. In this way, we can find out the yn plus derivative. That means we differentiating y2 terms first result n times by using Leibnitz theorem and find out the required second result. Thank you.